Let's begin this chapter with a quick recap of what we have learned about linear equations in two variables in the previous classes. We have learned that an equation which is in the form ax plus by plus c is equal to 0, where a, b and c are real numbers and a and b are not both 0, is called a linear equation in two variables x and y. The solution for linear equation are a pair of values, one for x and the other for y, which makes the two sides of the equations are equal. Given two lines in a plane, only one of the following three possibilities can happen. 1. The two lines will intersect at one point. 2. The two lines will not intersect, that is, they are parallel. 3. The two lines will be coincident. Example of linear equations in two variables: 2x plus 3y minus 7 is equal to 0, 9x minus 2y plus 8 is equal to 0, 5x is equal to y, minus 7x plus 2y plus 3 is equal to 0. In this chapter, we shall explore more about linear equations in two variables.
At the end of this chapter, you will be able to solve linear pair of equations algebraically and graphically, determinant method of solving simultaneous equations, Cramer's rule, conditions of consistency of equations, solve linear pair of equations using cross multiplication method, reducing equations to a pair of linear equations in two variables.
Example 1. Gautam went the newly opened mall with his friend. There he played snooker and hit the aim game. The number of times he played snooker is half the number hit the aim played. If each hit the aim game costs ₹3 and a game of snooker costs ₹4, what is the number of hit the aim game and snooker be played, provided he spent ₹20? Note: when one of the variables is 0, the equation reduces to a linear equation in one variable, which can be solved easily. For instance, putting x equal to 0 in equation 2, we get 4y is equal to 20, that is, y is equal to 5. Similarly, putting y equal to 0 in equation 2, we get 3x is equal to 20, that is, x is equal to 20 by 3. But as 20 by 3 is not an integer, it will not be easy to plot exactly on the graph paper. So, we choose y equal to 2, which gives x equal to 4, an integral value. Plot the points A, 0, 0, B, 2, 1 and P, 0, 5, Q, 4, 2 corresponding to the solutions in table. Now draw the lines AB and PQ representing the equations x minus 2y equal to 0 and 3x plus 4y equal to 20 as shown in figure. Note: we can observe that the two lines representing the two equations are intersecting at the point 4, 2. Example 2. Ranjan went to a stationery shop and purchased 2 books and 3 erasers for ₹9. His friend Sonali saw the new variety of books and erasers, and she also bought similar 4 books and 6 erasers for ₹18. Represent this situation algebraically and graphically. We plot the above points and draw the lines. We find that both the lines coincide. This is so because both the equations are equivalent, that is, one can be derived from the other. Example 3. Two rails represented in the form of equations x plus 2y minus 4 is equal to 0 and 2x plus 4y minus 12 is equal to 0 cross each other. To represent the equations graphically, we plot the points R02 and S40 to get the line RS and the points P03 and Q60 to get the line PQ. We observe that the lines do not intersect anywhere, that is, they are parallel. Example 1. Algebraic verification. X is equal to 4, y is equal to 2 is a solution of the given pair of equations. Substituting the values of x and y in each equation, we get 4 minus 2 into 2 is equal to 0 and 3 into 4 plus 4 into 2 is equal to 20. So, we have verified that x is equal to 4, y is equal to 2 is a solution of both the equations. Since 4, 2 is the only common point on both the lines, there is one and only one solution for this pair of linear equations in two variables. Thus, Gautam had played snooker 4 times, hit the aim twice. Example 2. Find the cost of each book and eraser. We have seen that the situation is geometrically shown by a pair of coincident lines. From the graph, we observe that every point on the line is a common solution to both the equations. So, the equations 2x plus 3y equal to 9 and 4x plus 6y equal to 18 have infinitely many solutions. By dividing the equation 4x plus 6y equal to 18 by 2, we get 2x plus 3y equal to 9, which is same as equation 1. That is, both the equations are equivalent. Any point on the line gives us a possible cost of each book and eraser. For instance, each book and eraser can cost rupees 3 and rupee 1 respectively, or each book can cost rupees 375 and eraser can cost rupees 0.50 and so on. Example 3. Find whether two rails cross each other. The situation is represented geometrically by two parallel lines. Since the lines do not intersect at all, the rails do not cross. This also means that the equations have no common solution. Based on these three examples, we can gist some findings. A pair of linear equations which has no solution is called an inconsistent pair of linear equations. A pair of linear equations in two variables which has a solution is called a consistent pair of linear equations. A pair of linear equations which are equivalent has infinitely many distinct common solutions are called a dependent pair of linear equations in two variables. We can now summarize the behavior of lines representing a pair of linear equations in two variables and the existence of solutions as follows. The lines may intersect in a single point. In this case, the pair of equations has a unique solution, consistent pair of equations. The lines may be parallel. In this case, the equations have no solution, inconsistent pair of equations. The lines may be coincident. In this case, the equations have infinitely many solutions, dependent, consistent pair of equations. Let us now write down and compare the values of A1 by A2, B1 by B2, and C1 by C2. Here, A1, B1, C1 and A2, B2, C2 denote the coefficients of equations given in the general form in section.
Determinant method of solving simultaneous equations. To overcome the limitations of graphical method for solving simultaneous equations, we use the determinant method of solving simultaneous equation. If A, B, C, and D are any four numbers, the value of AD minus BC is represented as AB, CD. This type of representation of number is called as determinant of order 2, as it has two rows and two columns. Let the given simultaneous equations be A1x plus B1y and C1 and A2z, A2x plus B2y is equal to C2, where A1, A2, B1, B2, C1 and C2 are the real numbers such that A1, B2 minus A2, B1 is not equal to 0, and x and y are variables. Let us solve these equations by equating the coefficients. A1x plus B1y is equal to C1, equation 1, and A2x plus B2y is equal to C2, equation 2. On multiplying equation 1 by B2 and equation 2 by B1, we get A1 B2x plus B1 B2y is equal to C1 B2, equation 3, and A2 B1x plus B1 B2y is equal to C1 B1, equation 4. Subtracting equation 4 from equation 3, we get A1 B2x plus B1 B2y is equal to C1 B2. A2 B1x plus B1 B2y is equal to C2 B1. Minus 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 upon A1 B2 minus A2 B1 is equal to C1 B2 minus C2 B1.
The cost of 5 oranges and 3 apples is rupees 35, and the cost of 2 oranges and 4 apples is rupees 28. Let us find the cost of an orange and an apple. Solution: let us denote the cost of an orange by rupees X and the cost of an apple by rupees Y. Then the equations formed are 5x plus 3y is equal to 35, that is 5x plus 3y minus 35 is equal to 0 into 1. 2x plus 4y is equal to 28, that is 2x plus 4y minus 28 is equal to 0. Let us use the elimination method to solve these equations. Multiply equations 1 by 4 and equations 2 by 3. We get steps of solving linear pair of equations. Step 1. Write the given equations in the form 1 and 2. Step 2. Taking the help of the diagram above, write equations as given in 8. Step 3. Find x and y provided A1 B2 minus A2 B1 is not equal to 0. Step 2. Above gives an indication of why method is called the cross multiplication method. Let's work out some examples based on cross multiplication method. Example 1. From a bus stand in Bangalore, if you buy 2 tickets to Malleswaram and 3 tickets to Yashwantpur, the total cost is rupees 46. But if we buy 3 tickets to Malleswaram and 5 tickets to Yeshwanthpur, the total cost is rupees 74. Find the fares from the bus stand to Malleswaram and to Yeshwanthpur. Solution. Let rupees X be the fare from the bus stand in Bangalore to Malleswaram and rupees Y to Yeshwanthpur. From the given information, we have 2x plus 3y is equal to 46. That is, 2x plus 3y minus 46 is equal to 0. 3x plus 5y is equal to 74. That is, 3x plus 5y minus 74 is equal to 0. To solve the equations by the cross multiplication method, we draw the diagram as given below. X upon 3 into minus 74 minus 5 into minus 46 is equal to y upon minus 46 into 3 minus 74 into 2 is equal to 1 upon 2 into 5 minus 3 into 3. X upon minus 222 plus 230 is equal to y upon minus 138 plus 148 is equal to 1 by 10 minus 9. X upon 8 is equal to y upon 10 is equal to 1 upon 1. X upon 8 is equal to 1 by 1 and y upon 10 is equal to 1 upon 1. X is equal to 8 and y is equal to 10. Hence, the fare from the bus stand in Bangalore to Malleswaram is rupees 8 and the fare to Yeshwanthpur is rupees 10. Example 2. For which values of p does the pair of equations given below has unique solution? 4x plus py plus 8 is equal to 0. 2x plus 2y plus 2 is equal to 0. Solution. Here a1 is equal to 4, a2 is equal to 2, b1 is equal to p, b2 is equal to 2. Now for the given pair to have a unique solution, a1 upon a2 is not equal to b1 upon b2. That is, 4 upon 2 is not equal to p by 2. That is, p is not equal to 4. Therefore, for all values of p except 4, the given pair of equations will have a unique solution. Example 3. For what values of k will the following pair of linear equations have infinitely many solutions? kx plus 3y minus k minus 3 is equal to 0. 12x plus ky minus k is equal to 0. Solution. Here a1 by a2 is equal to k by 12, b1 by b2 is equal to 3 by k, c1 by c2 is equal to k minus 3 upon k. For a pair of linear equations to have infinitely many solutions, a1 upon a2 equal to b1 upon b2 is equal to c1 upon c2. So, we need k upon 12 is equal to 3 upon k is equal to k minus 3 upon k, or k upon 12 is equal to 3 by k, which gives k1 is equal to 36, that is, k is equal to plus minus 6. Also, 3 upon k is equal to k minus 3 upon k, gives 3k is equal to k2 minus 3k, that is, 6k is equal to k raised to the power of 3, which means k is equal to 0 or k is equal to 6. Therefore, the value of k that satisfies both the conditions is k is equal to 6. For this value, the pair of linear equations has infinitely many solutions. Now, let's discuss the solution of pairs of equations which are not linear but can be reduced to linear form by making some suitable substitutions. We'll understand this process through some examples. Example 1. Solve the pair of equations 2 upon x plus 3 upon y is equal to 13. 5 upon x minus 4 upon y is equal to minus 2. Let us write the given pair of equations as 2 into 1 upon x plus 3 into 1 upon y is equal to 13. 5 into 1 upon x minus 4 into 1 upon y is equal to minus 2. These equations are not in the form ax plus by plus c equal to 0. However, if we substitute 1 upon x is equal to p and 1 upon y is equal to q in equations 1 and 2, we get 2p plus 3q is equal to 13, 5p minus 4q is equal to minus 2. So, we have expressed the equation as a pair of linear equations. Now you can use any method to solve these equations and get p equal to 2, q equal to 3. You know that p is equal to 1 upon x and q is equal to 1 upon y. Substitute the values of p and q to get 1 upon x equal to 2, that is, x is equal to 1 upon 2. 1 upon y is equal to 3, that is, y is equal to 1 upon 3. Verification. By substituting x equal to 1 by 2 and y equal to 1 upon 3 in the above equations, we find that both the equations are satisfied. Example 2. Solve the following pair of equations by reducing them to a pair of linear equations. 5 upon x minus 1 plus 1 upon y minus 2 is equal to 2. 6 upon x minus 1 minus 3 upon y minus 2 is equal to 1. Solution. Let us put 1 upon x minus 1 equal to p and 1 upon y minus 2 equal to q. Then the given equations 5 into 1 upon x minus 1 plus 1 upon y minus 2 is equal to 2. 6 into 1 upon x minus 1 minus 3 into 1 upon y minus 2 is equal to 1 can be written as 5p plus q is equal to 2. 6p minus 3q is equal to 1. Equations 3 and 4 form a pair of linear equations in the general form. Now, we can use any method to solve these equations. We get p equal to 1 by 3 and q equal to 1 by 3. Now, substituting 1 upon x minus 1 for p, we have 1 upon x minus 1 is equal to 1 upon 3. That is, x minus 1 is equal to 3, that is, x equal to 4. Similarly, substituting 1 upon y minus 2 for q, we get 1 upon y minus 2 is equal to 1 upon 3. That is, 3 is equal to y minus 2, that is, y is equal to 5. Hence, x is equal to 4, y is equal to 5 is the required solution of the given pair of equations. Verification. Substitute x equal to 4 and y equal to 5 in 1 and 2 to check whether they are satisfied.